In this tutorial, we'll be learning about literals and constants. So literals and constants, we know what literals are and we know what constants are and how to declare them. So what's a literal? A literal is used to express a particular value within a source code of a program. So that's simply what a literal is. And examples are integer literals where we can have a number like 75. When you just write 75, it's a literal. So you can say cout 75, and then you tell the computer to print this out, ENDL, to print this out, and it's what we call a literal. So it outputs 75. So this is what we call a literal. When you just pass this value, a number, a letter, a character, a string, without putting it in a variable, without packaging it in a variable, then it's what we call a literal. So let's say this is a literal 75. You can have a literal like negative 67. This is also what we call an integer literal. It's the same thing. Now we can have decimal format of these of integers, and you can have octal format of the integers. So let's print out this format, the octal format, which is 0113. So 0113 is the octal format, that's base 8 of the number 75. So let's run this and print it out to see what the output is going to be. So we get a value of 75 returned over here, right? So that is the octal format. And let's print out the hexadecimal format, which is base 16 of the same number 75. So 0x4b. This will print out 75, but this format is in hexadecimal format, which is base 16. Yeah, so it outputs 75. So you can have literal integer literals in this format. So I'll just go ahead and comment this out as usual. Now over here we have various formats, and we have looked at what long integers are unsigned and signed integers. We've looked at that in the previous video. If you missed it, please kindly check back on the playlist and you will find it there. Right, so when we just print this out, cout, at this point in time, the literals concept might still be vague. Yeah, it's no problem. As we go ahead in this tutorial and we use several examples, we'll get to a point that you would kind of get the intuition of what a literal is. Right, so over here we are calling 75u, right, and we are printing that out to the screen, ENDL. And let's run this. Shift B is my shortcut for build and run. You can change that in your settings. So it returns 75, right? Right now everything might look the same because let's do the 75L. Yeah, let's use L right now, and we're going to print these two values. So over here it still returns 75, 75, so the same thing. Now what we want to do is to as well print out the size of this size of this value. So 75u, and then we come over here. Let me just copy this and paste it over here. Right, so we're going to print out this. We'll change this to L. Right, so we are printing this value 75, and we are printing a size, and as well we are doing the same thing for this one. So let's just run it and see what happens. And there is an error over here. Sorry, it's size, not what I wrote. So good, so we run this and we get 75, 75, and 4, 4. So the 4 over here is the, right now you don't see it clearly, so I'll just put in a tab over here. So we have learned this one as well, tab, and then I put one here as well. Sorry, not here, between the 75 and the size of, so that it separates it out. Right, so I put this here and then delete this one. Right, so let's go ahead and run this, and the size is 4, 4. So that means the memory allocated for this is 4. What if I just leave it as u is still 4? Okay, so you can experiment with all of these ones, but this simply tells the computer to allocate a particular memory space for the literal that you are passing. Yeah, so let me just go ahead and comment out all of these ones so we move ahead. So right now we've talked about integer literals. Now we're talking about float point literals, And float points, as you know, can be decimal, they can be exponential, they can be negative, exponential with a negative exponent, and yeah, this is just a simple decimal. So this is what we call floating point numeral. Yeah, and they are literals as well. So the forms are, you can have 3.14L, where the L means a long double and then the F is for float. Please check out the previous video if you don't know what float, long doubles, and unsigned and signed integers are. So what I'm going to explain over here is the link between variables and literals. Now, as we have used in several examples previously, when I just say out, then call out, let's say 75, 76, and then print this is an integer literal. So I didn't package it in any variable. But then if I do package it in a variable, let's say I call it int a is equal to 76, right? If I do call it out this way and then write here a, now when you call a, 76 is going to be printed. Now the 76 here is a literal because it can't be changed. It will always be a literal within the computer. 76 will always be 76. Negative 64 would always be negative 64. Right, so that does not change. It's a literal. It doesn't change. But then when I put it in a variable a, the variable a is not a literal. Over here, the variable can change because when we get further in this tutorial, we will get to a point that we can iterate over a loop and then update the value of a variable. So the variable a can change. So it is not a constant. A variable can change. But if I put here a, right, and then come down and say a is equal to a plus 1, right, this a would get updated. It's no longer going to be 76. It will be 77. So let's go ahead and run this and see what is going to be printed, right? So 77 gets printed. Even though if I put 76 plus 1 over here, 77 would be returned. Let's run this. So 77 would be returned. But over here, these are two literals that I am explicitly adding. But over here, what I did was I put the literal in a variable. So just know that literals are, as we have defined up here, right? It's used to express a particular value within the source code of a particular value. So 76 is a particular value, 1 is a particular value, right? So I hope this clear things out on what a literal is. Right, so now we have character and string literals, right? And these are we have used several of these earlier, but in this tutorial we'll talk more on some of them. So what is the difference between y and, okay, so let me talk about what character literals are before we move to this difference. So a character literal is just, let's say y and then u, and I can have p. So these are all characters and they are character literals, and I can print them directly. And an example of a string literal is the most common hello world. This is what we call a string literal. So I can directly print this out on the screen by using cout and all of these commands, right? So I'll just clear this out without comment. Now, what is the difference between y and single quotation mark? So cout y ENDL and then cout y. What do you think the difference is? Right, so assuming you've given a go at it, y over here would be a variable because it's only variables you can pass directly this way using their identifiers, and then the value that has been stored against it gets printed. But then if I put this in single quotation marks, it makes it a character, and so y would explicitly be printed on the screen. So when I run this, I'm sure to get an error because I did not declare y initially as a variable. So let's run this and see what will happen. So I get an error over there, and it says over here that error y was not declared in this scope, right? That means that if I use it in the form of a variable, int y is equal to, let's say int y is equal to 6, and if I run this, I expect 6 to be printed here and I expect y to be printed here. So let's run this out and see what's going to happen, right? And I have 6 here and y over there. And so when you have a variable like sentence, and we have explained that earlier in previous videos. So right now we're talking about single character escape codes. What are they? And we have used an example like the tab. We used it earlier to give to give horizontal space within a line of code. Yeah. So we would be experimenting all of these ones to see what they do with this line of code. So over here, what this line of code does is prints out hello world, how is it going? Hope you are safe on the screen. So let's go ahead and run this to see what the output is going to be. Right, so we see hello world, how is it going? Hope you're safe. Right, now we're going to talk about the first one, which is \n. And what that does, it splits the line of code into two. so I can put it over here between the going and then the hope. So /n, and let's run this to see what happens. So we see that it was cut at where it was put. So the single line of code was cut into two. So that introduces a new line. So this can be used in place of the ENDL. So we'll go ahead and experiment with the /t, which we have already done severally. So /t here, shift B, and we see the tab, the horizontal space introduced over here, just like the normal tab would do. So we go ahead and then use the /v to see its effect. And we have a certain character output here. I don't really get what this means, why it did not show any particular effect here. So we just go ahead and then change it to I think the next one is /b, right? /b, and we run this to see its effect. And that's a backspace from over here. So we expect the letter before it to be deleted. So we have over here, hello world, how is it going? Hope you are safe. So there was a full stop over here, but it's been deleted. In order to get the real picture, I would be printing this line 2 times so we can easily compare. So see, so let me copy this and paste it. Right, so I would clear this and then right. So let's run this again to see the output so that we can compare them. So over here, the first one is the unedited one. We have hello world, how is it going? Hope you're safe. And the second one is hello world, how is it going? And we see the full stop being deleted over here because we have put the backspace escape character over there. So that deletes the letter before it. So let's put /a over here. And what that does is it introduces an alert, a beep. So /a, and we run this. Right, so I don't know if you have heard the sound I heard, because when I run this, I get that Windows beep, no, something like that. So when you introduce this, when you introduce this in your code, it outputs an alert that you can hear, an audible alert. You can try that out and then tell me if you experience the same thing in the comment section. So that outputs a beep. So then we come to the single quote, right? So we'll just use this. So it's / a quote, and we run this to see the effect. Right, so we see that single quotation mark over here. So that's what that one does as well. And now let's delete the / and just run this line of code to see whether without the / this single quote would appear. So as we can see, it appeared as usual as before. So I don't really know the effect of this / on this code. I don't really know its use because without it, this thing still appears. So if you know its real usage, you can comment in the comment section so we all learn. Right, so we move on to the next one, which is the / and double quotation mark. So we run this to see the output and we get a double quotation mark over there. Right, so I'll go ahead and delete this backspace and run this to see if there will be any effect. And I can already see there will be an error because the color of this is different from this. So what this means is that from this single quotation mark to the second one, this has been grouped as a legal string. But then this one is an illegal one because this last quotation mark doesn't have a correspondent over here. And even if it does have a correspondent, that would be illegal, unless of course you have two less than signs here to separate them. Let's say if you this is the first quotation mark, this is the first one, and this is the second one, right? So let's say if you want to have a quotation mark over here, you have to make it this way. Without this, it's illegal. Let's run it and see what the output is going to be. Okay, so it's not illegal to do what I just did. So it output the same thing. So we could have done this. But now the thing is, if I want to quote hope, just hope, right? If I want to quote hope, how do I go about it, right? Because if I do this, the code gets disorganized. So what I can do is I can use the backspace to escape those two quotes so that that appears within the code. So let's go ahead and run this to see. So I'll just clear this first quotation mark. So shift B. So over here we get double quotation marks around the hope, right? So without this one, there will be an error thrown, right? So we would go on to the next one, which is the question mark. So I'll go ahead and delete these ones. Okay, so we have a question mark over there with a backspace, right? So let me put a space over here. So around this to see its effect. And we have a question mark introduced over here after the going. Now, what if I delete this backslash and then just run this? What is it going to do? And we see the same output over here. So I don't really know the effect of this backslash on this particular in this particular case. If you know it, you can comment, you can leave a comment below. Now we have the last one as a backslash. So let me clear this one and then introduce a backslash, and we run this to see what the effect is going to be. So this backslash gets appeared here. The first one appears, disappears, and the second one appears. So what we can do over here, what we can see over here is that, let's say you want to put in an alternative. So hello world, how is it going, slash hope or something, I don't know. So if you want to introduce a slash in your code, you can use this to escape your character. So let's clear this and then we see whether there will be any effect. Yeah, and over here the backslash did not appear over here, right? So if you need just one backslash, you have to escape it, right? But if you don't need this backslash and you want to use a forward slash, you don't need to escape it. You just run it this way and the forward slash should appear. Yeah, so we have it appearing here, right? So I hope you get the difference. So we have come to this section, and what am I to explain over here? Right, so it's also the usage of these backslashes, the escape sequences. So let's say these numbers and letters and characters are stored in the computer as in a numerical system, so you can have them in binary format, zeros and ones. This is the hexadecimal format of a character, and this is the octal format of a character. Let's go ahead and run this and then use a second example to illustrate what I mean. So I would go ahead and shift B, run this to see the output. So we get HH over here as the output. So what this means is that these characters are the representation of the letter H, the small letter H in the computer's memory. Let's go ahead and then go to Google, to the ASCII value tables to get one. Let's say which letter should we pick? Let's pick W. So we are picking W, and the octal, so this is the octal column and this is the hexadecimal column, right? So we're picking W, and the hexadecimal format is 77 and the octal format is 167. 77 167. So we come over here, so we have 77 and 167, just so I don't forget. So over here I would print this value out, so C out, and we should put it in a character format, right? Character format. And then the first thing is a backslash and then 77. So the 77 here is the hexadecimal format, and if you're using the hexadecimal format, you have to introduce an X before it so that it gets printed. So that's the syntax. Then we end it with an end line over here. Then we come down here to use the octal format. So it's going to be a character, and it's going to start with a backslash, and then for the octal format you can just write it directly without any X in front. So that is the syntax, right? It's a rigid rule you have to follow. Then we end it with an end line and semicolon. So let's go ahead and clear this out. So when we run this, we are expecting two H's and two W's, right? So let's run this and see the output. Okay, so we get the two W's over here and then two H's over here. So that's another usage of the backslash to escape certain things and to print the hexadecimal and the octal formats of characters and numbers. And right now I have a string, right? I have a string X, and it's equal to string expressed in a single line, written in a multi-line, but then you have it printed as a single string. So let's go ahead and print this to see what the output is going to be. Oops, so it did not get printed because I did not call out cout. So I'll call out cout and then print out x, and then this is going to be end line, right? And we get string expressed in a single line over there, single lines over there. So let's just clear this s, right? So what happened here was that you can see that it is written in multiple lines. It's a multi-line string, but then it gets printed straight. That's because we used this backslash over here to join these all of these strings. So let's write out another example. So let's say string y, let's use z, string z equals, so we have this is a second multi-line string, right? So this is a second multi-line string appearing in a single line format. So what I can do here is to introduce my backslash over here and then enter. So that will introduce a new line. Then I'll come over here, backslash over here, then enter, and then a backslash over here and enter. So let me introduce the backslash here, right? So this is a string z, and note that all of these backslashes were within the two quotation marks. So the two quotation marks, double quotation marks, must be at the end of this string, right? But then these ones, the backslashes will come at the end of each line so that they all appear joined at the output. So let's go ahead and clear this x and replace it with a z, because that's what we want to print. So we run this and we get an error. So what's the error? Expected comma or this before cout, right? So I should put a semicolon over here. So we run this and we get this is a second multi-line string appearing in a single line format, and you can see that there are spaces over here. So what we can do is we can reduce the spacing before that, just like this. So a space, just a space will do, like that, like that. So we go ahead and run it to see the output, and now we get it in the standard format with just one space between each word, right? So that is that application. Now one thing I want you to notice is that when I comment this out, right, so this is 3 lines, and when I comment this out over here, right, let me comment this one out, and you see that all the 3 lines get commented out. Let's do this one again and see the effect. I comment out, sorry, so I comment out this, and we see that everything, all the 3 lines get commented. If I have a second line over here, right, if I have a second line over here and a third over here, and I comment out this one, only this one gets commented. The second and third did not get commented out. So this might be an unofficial way of commenting, a multi-line comment. So let's say the usual way of multi-line commenting is in this format. So I have multi-line comments as such, and I want to comment it out. I'll just use /* and then over here */. So this is the official format syntax to do multi-line commenting. But over here, I could comment 1, 2, 3, 4 lines with just 2 backslashes. So if you want to write a multi-line comment, instead of doing this, you can introduce backslashes over here as we have seen. So backslashes over here, and the computer interprets it as 1, right? So we introduce backslashes here, and then just 2 /, and then everything gets commented out. So this is something I came to realize accidentally. Yeah, so this might be an unofficial way of commenting out. Yeah, so you can take note of that if you want to use it.